have the possibility of being able to run prediction-oriented solutions, or maybe pattern recognition, or information discovery, or adaptive control-based solutions by training your model with some past known data samples. Like we are just learning something by reading a book, going to school, or listening to some webinar or lecture like I am doing now. Like the human-oriented training and educational time periods, your algorithms, your machine learning algorithms need data to be trained, and they are also just tested in terms of some, again, known data scenarios. And after they pass such tests, you will be or you can be able to use them in terms of feature scenarios. For example, prediction means finding or predicting the future states of an unknown case, like medical diagnosis, for example, like predicting the success rates of students for future examinations, or predicting, for example, a student's future job by considering the past samples of data, including his or her lecture notes, lecture grades, or quiz or exam grades, for example. And considering the medical diagnosis, you just run some past diagnosis oriented values, which are just derived or created by doctors, maybe, in order to perform an adaptive diagnosis oriented artificial intelligence based systems to predict a disease like cancer or diabetics or COVID-19. You just use a system to predict future states. And in terms of pattern recognition, your system is trained to be having some or detecting some connections between data. In terms of, for example, earthquakes, you can be having some past data to detect some connections between the earthquakes, so your system can be having some pre-knowledge to predict some or to have some patterns for the future earthquakes. It needs some data flow which includes some connections in terms of time, for example. So that means pattern recognition. And information discovery means creating a new data. For example, developing a drug or developing a vaccine for the COVID-19 includes such problem solutions. And in terms of cybersecurity, we should be, for example, having some ideas about predicting the future cybersecurity grade of a company, for example, by considering some data of the computers and digital systems that company is actually using, having a number of antivirus software installed in the computers, and having number of attacks previously, or having numbers of or considering the total numbers of security experts, for example, and combining all of these data, you can be having a machine learning oriented system to predict the future grade of your cybersecurity for your company or for your country, for your individual state, for example, considering your individual cybersecurity components. And considering the discovery oriented things, you can be maybe in terms of black hat sites, for example, you can be having some machine learning based systems to derive some malicious codes, including artificial intelligence based codes, for example. The use of AI in terms of cybersecurity is not associated with the light side. Of course, the dark side, the SITs may be using, the black hat hackers may be using such systems to have some intelligent autonomous systems to perform cyber attacks. So we should be careful about considering the balance to be using AI and machine learning in terms of both sides of cybersecurity. And adaptive control maybe includes the use of some adaptive management and control of the cyber defensive side of your system, considering like AI-based pen test tools or software systems, for example. But the main point that I have just explained in a few minutes ago, every field, including the cybersecurity, needs the similar use of algorithms and AI-based solutions. But the exact point is the data you are having. if you have the data to derive a scenario in terms of cybersecurity, you can be using the same artificial neural network for performing some prediction-oriented problem. And considering the data like a medical diagnosis, you can be using again the same algorithm for the prediction purposes. The problem is different, but the way the solution method is very similar, dear friends. The most important thing is which data you will be using, how you have gathered your data to form your scenario, because if you miss any critical component in terms of predicting the cybersecurity point grade, for example, you have a weak AI-based systems to make a good prediction for your problem. So that's very important, dear friends. And of course, when we talk about machine learning, we have the data. We can be having some feature extraction, which means, for example, when you are learning something about a target course, you just have some brief information from your friends. You have some notes, not reading all the book, but having some brief notes from your friends. You will be able to learn better in a shorter time about the target course or target topic of your course, for example. So that means you can be using the data to train or the direct use of your AI or machine learning based system. But if your data is complex and needing some feature extraction in terms of making your system to learn better about the target problem, and in order to use the time more efficiently, you can be using the feature extraction based methods like image processing, like signal processing. These are all data processing oriented components, like in terms of talking statistics, like having some subgroups from a main population. For example, you have some a big amount of data, and you take some samples from that big data to have less data, but enough, effectively enough data group to run your machine learning oriented system. So that's the way of the using AI and especially machine learning oriented systems for your target problem. And that can be even cyber security side problems, dear friends. And when we talk about the data, of course, you can be having your modeling of your data with different perspectives. For example, you can be having some expert-based knowledge rules, like saying that if that's the first parameter is that value, and the second parameter is that value, and the third one is that value, and that becomes that result, for example. Like considering that, yes, your system has previously done many numbers of cyber attacks, and you have less usage of antivirus software, and the third parameter is your staff's knowledge about cybersecurity awareness is very low. So because of that three parameters, if that is that one, and if the second one is that one, and if the third one is that one, then that belongs to that's your cyber security level of your company is low, for example. That's one rule, just one rule. But all of these three parameters is great by using the AND connection, or maybe by using sometimes OR connection in terms of logical connections to use if then else rules. For example, you can be using such rule oriented components to model your especially machine learning, not machine learning oriented, but for example fuzzy logic based systems, to use some inputs to read some outputs, for example, in terms of cybersecurity or other problems. But when we talk about machine learning, we have some learning styles. For example, supervised learning needs input-output balance at the same time, and unsupervised learning, which means also clustering, needs only input data. It's not important to have outputs. You may not be having any idea about which outputs are considered for these past samples of inputs, and your system determines. For example, you say that you can be grouping that inputs into 5 different number of classes, so it performs unsupervised learning. But when we talk about supervised learning, you have some past samples of inputs, and you all know about